Hello students and welcome to Roots, Factors, and the Rational Root Theorem, and this video is just about roots and factors. So right now we're going to look at roots and factors, and that is on page 8 of your notes. So the root of a polynomial is an x value that makes the polynomial equal 0, and you can think of them as x-intercepts. And the kind of cool thing is that there's a relationship between x-intercepts and factors. So if you know the roots, you can get the factors. If you know the roots, you can get the factors. So you won't necessarily need to do reverse box method every time. So that's kind of cool, just an option for you. So I'm going to show you a few examples first. So I'm going to start with number 1. And I've got this polynomial, x squared plus 3x minus 10. And I need to figure out the roots. Now I've given them to you here, but I want to show you how to do this in the calculator. So add a calculator page, and then you're going to go Menu, Algebra, Polynomial Tools, and then find roots of polynomial. And then degree is the biggest exponent, so it is degree 2, and then leave it as real. And then you're just going to put in your coefficients. So my coefficient for x squared is a 1, my coefficient for x is a 3, and my constant is a negative 10. And then just press enter a couple of times until it puts that on your calculator. And then press enter, and it tells you that the roots or x-intercept are negative 5 and 2. So these are my roots or x-intercepts right there. Now, once I get these out of the calculator, I can figure out the factors without resorting to all this work. I don't have to do all that work. I can do this instead. So take a look at the example I gave you. One of my x-intercepts or my roots is negative 5. Well, that translates into the factor x plus 5. And if you look at the difference there, all that happened is that the sign flipped. So x equals negative 5 turned into x plus 5 as a factor. So flip the sign. And then the x-intercept positive 2 turned into the factor x minus 2. So again, all we had to do was flip the sign. And those are the factors of this. And in fact, we can confirm that. Let's check our work. X squared plus 3x minus 10. So that works. So often it can be as easy as that. Put your polynomial into your calculator to figure out what the roots are, and then just flip the signs, and there's your factors, and you don't have to do box method at all. So let's try another one. And by the way, there is a typo on this one. This should be plus 15. So please fix that first. So plus 15. So let's try it again. Let's say you were given this polynomial and you were said, factor this. So all you're going to do is grab your calculator, be on a calculator page, and press Menu, Algebra, Polynomial Tools, and then find roots. This is still degree 2 because that's the biggest exponent. Always leave it on real, for now anyway. And then put in your coefficients. So 1, negative 8, positive 15. Press enter a couple of times until it obeys. And then press enter, and there's your roots, 3 and 5. Now I already gave them to you, but if I hadn't, that's how you would find them. So now that I have the roots, all I have to do to find the x-intercepts, all I have to do to find the factors, we found the x-intercepts, is flip signs. So x equals 3 becomes the factor, let me not write in green that you can't read, how about blue? X, and flip the sign, minus 3, and x, flip the sign, minus 5. So your factors are x minus 3 and x minus 5. And let's just check this one too for good measure, why not? And in fact, I do get x squared minus 8x plus 15, so that worked. Yay. So really what you're working on the notes here is the relationship between these two. If you feel like you need practice on box method, then you can go ahead and fill this out. So box method. If you need practice multiplying, you can do that. But not all of you do. Some of you are really good at it, so you can kind of leave that alone. What I'm really concerned about is this part here. So let's do a few more. If my factors are x and x plus 1, what would the roots be? Now you could graph it to check, but let's work on this relationship. What do we know about this relationship? Well, we know that they just have the opposite sign. So I know that instead of x plus 1, my root is going to be x equals negative 1. In this one, notice it's not plus or minus anything, so it's just x equals 0. So there's my roots and my factors. Let's try one more. Actually, no, I'm going to have you guys answer these right now and then see if you got them right. Okay, now let's check out the next one. What makes this one different? Well, it's got a fraction. It's not an integer anymore. It's a rational number, but that's okay. Let's look at what happens because I've given you the factors and the roots already. So let's just see what the relationship is. So the x equals 1, we know that this root becomes this factor. That one's good. Yay. What we're not quite sure about is how this becomes this. So let's examine it. So notice I still have a positive 3 and a negative 3. So the sign still flips. But then notice that this 2 times x becomes a division. So it's like you're dividing it away. And really where that comes from is this. So this is what happens. You have 2x plus 3, and you have to go all the way back up to the definition. A root of a polynomial is an x value that makes the polynomial equal 0. Set it equal to 0. Now how do I get the x by itself? Well, I subtract 3 and then divide by 2. So that's how this came about. But all you really need to remember is the fact that the sign flips and this number becomes your denominator. In fact, later in the unit, I want to say page something, page 14, when we get to page 14 and we look at bottoms up, you're going to see this concept again. So just know it'll come back. So let's try that concept out here. So we've got x equals 4. That's an easy one. We know that factor will be x minus 4. And then so let's work on this one. Right, I'm starting to like this orange. I don't know why. Orange pen. Okay, so x equals 3 over 2. So what is that factor going to be? Well, I know I'm going to start with x, but leave some space. X. I know I'm going to have minus 3 because I know the sign flips. And then I know that that denominator used to be in front of the x, so I'm just going to put it back in front of the x. And there's my factor. So my factors are 2x minus 3 and x minus 4. Bam, that's it. So let's try one more. We're going to do these together. These three right here. And then I'm going to have you guys try some of these. So let's try the next one. So I have x equals negative 1. So flip the sign. And you're going to get x plus 1 as your factor. And then for this one, my fraction, I know the sign's going to flip, so I'm going to have a plus 2. And I know my denominator used to be pulled up in front of the x, so I'm going to have a 5x. And that's it. There's my factor. So let's do one that goes the other way, and then I'm going to have you guys try the rest. So x and 2x minus 4. So I know from before that if a factor is x, then one of my roots is 0, so just go ahead and write that one down. That one. And then I know I'm going to have my fraction one. So x equals, I know the sign on this one flips, so it's going to be a positive 4. And I know I have to divide away that 2. And so there it is. But 4 over 2 can be simplified, so go ahead and simplify that to 2. So my roots are 0 and 2. Okay, so go ahead and try the next ones. Some of them have 3 factors, but that's okay. You just do the same exact thing and then continue the video to check. So here's our last 3. So 2x minus 1, flip the sign, put the 2 underneath, you get 1/2. And then x equals negative 1/3, flip the sign, the 3 gets divided, goes on the bottom. Then the next one, 5x minus 2, came from 2/5, so flip the sign. And then the denominator gets pulled up next to the variable. And then 4x minus 5 came from 5/4, so flip the sign, minus 5. And then the 4 gets pulled up next to the variable to multiply. And then we have x equals 3/5, which came from 5x minus 3. Oops. Then x plus 1 gives us the root x equals negative 1. And 3x plus 5 gives us x equals negative 5/3. And finally, x equals 0 we know corresponds to the factor x. The root 2/3 gives us 3x minus 2 as a factor. And the root x equals negative 4 gives us x plus 4 as a factor.